You're thinking, since this is an absolute value function, we're going to have the positive version of the stuff inside, or the function, right? And we're going to have the negative version of the stuff inside. So you're really thinking that we're going to have something like 2x minus 5 sometimes, and then the other time we're going to have something like negative 2x minus 5. Come on, interact with the thoughts of others, including mine.
Oh, I believe that it wouldn't be negative 2x minus 5. It would be negative 2x plus 5, because you have to take the opposite method of both, or everything in the or absolute value.
Thank you, Tate. Absolutely. So you're saying, like, I really needed to take the opposite of the whole thing, not just the first term, right? Like, so we need to make sure that we're taking the opposite of the whole thing. And I think that's what Jerry meant, right? Because I was playing devil's advocate here. So she's saying, like, we're going to have the positive and negative version of the whole function. So I've got the whole function, and then I've got the opposite of the whole function, right? Now, I'm going to, what Tate's saying is we could go ahead and get rid of those parentheses if we wanted as well. So I'll go ahead and do that over here on the other side. So we're saying f of x equals, and Jerry Lee's setting us up for a nice piecewise function here. So it looks like something like this, and then Tate got us that nice, hey, distribute the negative, you silly teacher. Got it. Okay, so talk more about this. Like, so how are we going to figure out when each piece applies?
You need to graph it out and crosses the x-axis at 2.5.
Ah, so when you say it, Tim, what did you mean it crosses the axis at 2.5?
Equation for the line 2x minus 8.
No, I'm cool with that, Tim. Just say it.
On the equation for 2x minus 5, it crosses the line at the point 2.5.
So Tim's saying, hey, if you were to graph the line, just the inside stuff, right? If we just pretend like the absolute value isn't there, because that makes it hard, so let's just ignore that for a second. He's saying, look, it would cross the x-axis at 2.5, right? Or 5 halves. I can go with 2.5. That's cool. So how does this picture, and we can definitely see this because we know it has a positive slope and a negative 5 as a y-intercept, right? Like we've got all this from previous classes. How would this graph then help us? In what ways can this picture really help us see things?
I was kind of thinking that absolute value is like, it's there to make things positive. So after the line goes into the negatives, after 2.5, that's when you would want it to be reflected.
I love it. So you even said, like, hey, this is that spot where we actually want to reflect it up. And you're saying, like, that's why Jerry Lee threw that negative on for us anyway. So you're saying that this is the section where we actually need to worry about, reflecting it or having that negative out front. And so that really means for us when x is less than 2.5, right? Because that's where that yellow stuff is. And then obviously that means for us this other part right up in here, that's good. So that's the portion where we don't have to worry about it. And then I'm done, right?
I think both of them would include the 2.5. So it would be like less than or equal to.
You see the red thing that we were just told to be put on? Keep going. Interact with thoughts of others. You guys have been doing a pretty good job so far. I wouldn't put it on both. Because then if you think about it, if x actually was 2.5, where are we saying which function are we saying to put it in? Actually, we kind of know, don't we, Trevor? It's both, isn't it?
Well, yeah, but we should make it so that one of them is just a less than or equal to sign, and then one of them is just a less than or greater than sign, so that we know which equation we're using at 2.5.
So you're saying to communicate clearly to whoever reads our function, we want to make sure it only gets included one time so that person knows exactly how to identify the value.
Yes.
Perfect. Okay, so then where do we need to include it?
It could be either. You could use it with the top function or the bottom one because it's the same point.
So you're
Just as long as one.
So you're saying, like, look at that red point. It doesn't matter if we use green or yellow. It's still going to go through that red point.
Yeah.
So it doesn't matter where we include it. So we could include it one place, or we could have included in the other place as long as we include it somewhere.
Mm-hmm.
What questions do we have on this one?
I was just wondering about the 2.5, whether you could make a separate like rule for it and say that.
Yeah, so you're kind of cutting out there, Alicia, but I hear what you're saying. Are you wondering, could we have just done this?
Yeah.
I mean, would that make it wrong?
I don't think so.
No, and nobody seems to think so. I think for mathematicians, you're now adding a third function rather than just including that point in one of the two we already have. So it's more complicated, but it's not wrong. Does that make sense? So I think we really want to focus on the fact that we can do just what's in white, with that red addition somewhere. But you're absolutely right. We could actually include a third line if we really wanted. Okay? I'm just not going to, because for me it's all about keeping it as simple as possible and being as lazy as possible. So identifying just two functions is lazier than identifying three. And I like that. I want to, I don't want to do extra work for myself. So the other thing I want to point out is just a slight difference. I absolutely love what Tim did by saying, like, let's graph this to figure out when each one applies. The other thing I could have done is I could have just wondered, and I'll do this in purple, like, when is this thing 0? Right? And ultimately, if I solve that, I'll get 5 halves, which is his 2.5. And again, the reason I would do that is because for me, if I didn't have the graph, I know that when this whole thing equals 0, that's when it's changing over from positive to negative or negative to positive. So I know that purple spot is really going to find for me anytime it crosses the x-axis, which is when it switches over from above to below or vice versa. And so I know that would at least give me, kind of those break points that I need to worry about. I see this idea, I don't see this idea. But ultimately, I think if you look at what Tim did by making the graph, by using another representation, it really helps us not only see where the break point is, but also which function to use when. And I think that becomes really helpful too. And that allowed Kristen to just be like, look, that's the spot where it needs reflected. So that's where we should. And that's awesome.